Let's start with the last session of today. We are going to talk about passwords. We have a speaker that was in Auth0.
Correct?
The fun fact about the next speaker is that we don't have any fun fact. Am I right?
I'm not that interesting, no.
So, I leave you the stage.
Thank you.
Welcome, Bellen.
Tend to wave my arms a bit, so it might go like this, but we'll give it a try. So, passwords are so 1990. Who uses a password on a daily basis? Of course, all of us, yeah. My real question is, who likes using a password on a daily basis? Liar. Well, maybe not. I am not one of those persons. I do not like using passwords. So this talk is going to be a little bit about me complaining about passwords and maybe see if there's a solution out there that can get us rid of passwords. So if you do love passwords, feel free to go and grab a coffee or a beer and come back for Joel's talk later. If not, sit tight and we'll get started. So let me quickly introduce myself. My name is Bellen. I'm from Belgium, and I'm a staff developer advocate engineer at Auth0. So if you don't know Auth0, we're an identity as a service provider, which basically means that we try to make authentication as easy as possible so you can all just focus on building what you actually want to build, your actual applications, leave the logging in to us. I'm also a Google developer expert, and you can find me on the internet as @samego. Cool. This is a JavaScript conference, so it only makes sense that I made myself npm installable. So if you're on npx@samego/about me, download half of the internet, wait a few seconds, you'll find all of the links to my social media and these slides on npm. And if you want to follow along on your own devices or at home, you can go to 1990.samego.tech and see these slides in your own browser. Cool. Let's get started for real. In this talk today, I'm going to talk a bit about a history of passwords. We're going to see a few types of passwords because there's multiple types, at least according to myself. We're going to look at passwordless authentication. And lastly, we're going to look at the Web Authentication API, which is a newer API. Well, it's been around for 2 years, more or less, but it's still new to most people. And it's maybe the future that gets us rid of passwords. So, a little history of passwords. Somewhere before Christ, a long, long time ago, there were the Romans. I think you're all familiar with the Romans, right? Definitely in Italy. And if one legion of Romans would encounter another legion of Romans, well, because they had such a huge empire, they didn't know anybody from the other legions, so they would use a password to see if they were friends or enemies. And if the password was correct, they would go for a beer. If the password was wrong, you can imagine what would happen, right? They were Romans after all. Then fast forward to the 10th century, and you have the story of Arabian Nights, or 1001 Nights, and in that story you have a bunch of thieves, 40 of them to be exact, who stole all of the gold and jewels in all of the world, or all of the kingdom, doesn't really matter, and they hid that gold and jewels in a cave, and the password to open that cave was? Open Sesame, exactly. This Open Sesame from that nice children's story from the 10th century is actually a password to open the cave and get rich. But let's get a bit more relevant. Let's fast forward a little bit to the modern age, to 1961 to be exact. Fernando Corbato was an MIT engineer, and he's been credited to be amongst the people that worked on the first time-sharing system. And back then, in the day, not everybody had a cell phone in their pocket, a laptop on their desk. They had one big computer in all of MIT, but they wanted to make sure that as many people could use that one computer, so they could all unlock a certain part of that computer, power, hard drive, whatever they wanted, with a password. So the first password might have been used with that time-sharing system. If we then fast forward to the 1970s, Robert Morris Sr. invented hashing, which means that at least the first 9 years of the computer age, passwords were saved as plain text. Now, if you take away one thing today, apart from I don't like passwords, please don't store your passwords as safe text in your databases. Thank you. And then in the 90s, hacking became more of an issue just because everybody wanted to be on the internet. And if there's more people and companies on the internet, there's more people that feel like they should try to hack and get too sensitive data. So more people, more hackers, more issues. So we had to be more creative and more clever in how we dealt with security, passwords, and so on. And 2022, we still use passwords. Boo. That's a little bit of history of passwords. They've been going on from as long as we can remember, and we still use them today, and I think it's time we get rid of them. But before I talk about getting rid of them, we'll see a few types of passwords. The first one, let me quickly explain what is a password, or what is a password to me. Anything that is a shared secret can be a password. This can be something that I tell this person, and only both of us know this. As long as it's a shared secret between one or more parties, to me, that's a password. And the first one is the one we use every day. When we log into our favorite websites, applications, services, it's a username and password string. A password is a string. Could be something like this. Please don't use this. It's hopefully something that looks a bit more like this, or maybe even this, but not this exact example, because if you lived on the internet for the past 10 years, you might have seen this in a comic somewhere. But the idea here is that your password should be quite long to be secure. And it doesn't have to be random data. This could also be some words that you can remember easily, as long as it's a good password, that you don't reuse your password, and it is sufficiently long, and maybe uses a digit in there and a symbol as well if you wanted to make it a bit more secure. And the good thing is, they can be hard to guess by others, which means that they're not as easy to brute force or to guess by hackers who want to try and steal passwords, if they're complex, if they're long enough, if they are good passwords. But this also means that they are hard to remember for ourselves. I only know one password, and that's a password to unlock my password manager, and my password manager knows all the other passwords, and I hope it stays like this. Who uses a password manager? Nice. I've never seen so many hands go up, so way to go, Italy. So they can be hard to remember. A password manager can help, but it's still annoying because you have to create a lot of different passwords and you won't be able to remember them yourself. The next example is a PIN code, 1234. I think if you use your banking cards in Italy, you have 5 digits. Us in Belgium, we use 4, depending where you're from. A PIN code can be a few numbers, a few digits, 1, 2, 3, 4, 5, 6 maybe, but they're usually relatively short. And the good thing is, they're fairly easy to remember. I can remember this 4-digit code that I used to get cash from the bank, and I have that same PIN code for multiple cards. Don't tell anybody, but it's easy to remember at least one PIN code. And they're usually used with access to a physical thing. So even if you know my PIN code, and I just told you that I have one PIN code for multiple cards, you also need access to those multiple cards. Or if it's the PIN code to your phone, or to a keypad next to a door for an apartment building, you also need access to those physical things in order for you to be able to use that easy-to-guess PIN code. So on itself, a PIN code is usually useless. But again, PIN codes are just numbers, digits. They're short because they're easy to remember, so they're also very easy for others to guess. Next up, a pattern. If you use an Android phone, you might have seen this. Who uses this on their Android phone? A few hands? Cool. And when I ask people about this, one of the main reasons they use this is because it's easy, it's convenient. After a while, you just get into it. You don't even think about entering your code or your pattern. You just swipe it without thinking. It goes into your muscle memory. But this pattern under the hood corresponds to a password as well. I'm not sure if they do it digitally or something else, but in the end, the pattern is just a password like a PIN code or like a string. It's something you use to unlock your phone. And the good thing is, it goes into your muscle memory. You don't even have to think. You don't even have to remember. You do it automatically. It's very easy to use. It's very user-friendly. But touchscreens often reveal the pattern as dirty spots. I don't think anybody of us cleans our phone screen every time we unlock it. So you might reveal that pattern as a dirty spot if you do it a few times, which is, well, it's not the best. And people are lazy. I am lazy. I think at least half of you are lazy as well. And people often tend to use their initial letter or their lucky number as a pattern. So if you do a bit of social engineering, you might be able to guess the pattern after all, because we tend to use one of those things. So what is my problem with passwords? I've mentioned a few times already that I don't like them. Let's look at an example. The most basic example we all know. We all use day in, day out, a username and a password. And the first time you log in, I cannot really type well when I'm in front of people, so I, of course, had it wrong. I try again, it goes wrong again. Third time's a charm, log in again. Nope, can't remember my password, so I just have to reset it, deal with it, reset my password, and try to remember the resetted password. So if I type a new password and reset the password, I get this message. Who's ever had this message before? A lot of us. My point still being, Passwords are really not user-friendly. They rely on either a password manager or memory and some other factors. They're the worst when it comes to user experience, and they're also often a weak spot in our security chain, in our security infrastructure, in our database data, everything we save. So passwords are not a good solution in 2022. They can be annoying. I already touched on this. Please use a password manager to help you remember. It already lets you remember those passwords, which means that you can use multiple passwords for multiple services. But user data can get stolen, even if you use a password manager. If your service that you're using your password with gets breached and they save it as plain text, I hope they don't, but if they do, they might be able to get to your passwords. And data breaches don't always include passwords, but they sometimes do. And the point here being, data is always a weak spot in your whole security chain. People are always trying to steal the data, and if it's hashed, if it's salted, your passwords, that's good, but still people are trying to steal your data, including passwords, all the time. And if you use Auth0, we have this feature that's called breached password detection that basically alerts both the user and the administrator of the website that, hey, somebody tried to log in with a set of credentials that we know have been leaked, that is in the database of leaked credentials, and they are forced to reset their username and password. We also have a new credential guard, which goes even further and looks on the deep web and the dark web for more credentials. But if you don't use Auth0, Chrome has an extension, and I think also built-in feature as well, that you can enable that will also alert you if you're using a set of credentials that has been known to be breached. So, very useful. So some tips for a good password. Use a reasonably long password. Length is more important than complexity, but try to use a reasonably long password and include some letters, capital, non-capital, symbols, and numbers. Don't use anything personal, because people might be able to guess this by social engineering, and don't reuse passwords. Don't use the same password twice for different services, because if one service leaks those passwords, well, people will try credential stuffing attacks, which basically means like we take a whole database of leaked passwords and try them against every website that we can think of to see if some of them work on these other websites as well. So please don't reuse passwords. Let's fast forward again and go to passwordless. The first way of doing passwordless authentication can be with a one-time password, which means it's a password. It's still a password, even though it's passwordless. Doesn't really make sense, but still. And it's a password that's valid for a one-time use. It often expires after a certain amount of time. So like after 30 seconds, 45 seconds, a minute, it might expire and you will get a new one-time password. And it's usually sent directly to the user. So it's not something that the user has to remember or generate on their own. It's something that is sent to the user. And this can be in an SMS. If you have two-second factor authentication enabled for some of your services, I hope you have it for all of your services, you might use an SMS-based second factor that will send you an SMS that you have to enter into the service as a second factor. And the cool thing is that iOS and Android will let you fill in those one-time passwords with the press of a button. For example, here I got a text message to log into my GitHub account, and iOS detects that there's a one-time password in that message. So my keyword on top says, hey, do you want to input this one-time password from your messages? Tap on it, and you're done. It's quite user-friendly, it's quite convenient. I like that. But the bad thing is that SMS messages can be intercepted. There's always people trying to imitate real transmission antennas and all and stuff like this. So it's not 100% secure. And this does happen, not to all of us, but it does happen out in the world. And also, you need your cell phone on hand, so if you're trying to log in on your laptop and your cell phone is in your bedroom upstairs, you have to run all the way upstairs, get your cell phone, run all the way downstairs again before you can actually log into this. So it might be annoying as well. Another way for you to receive those one-time passwords is in an email, and it could even look something like this. If you use Slack, they have this feature where you can send a magic link. If you click on that link, you get logged in. In this link will be a one-time password as a query parameter that then Slack will use to log you in. So it doesn't even have to be a real code sent into an email. It can also be a magic link. And the good thing is, you don't need a second device, because most of us have our email set up on all the devices we use on a daily basis. At least I do. But again, emails can also be intercepted. They're not 100% secure. Lastly, an authenticator app. Google Authenticator is the most common one. Twilio has the Authy app. And we at Auth0 have the Guardian app that all do the same thing. They generate a one-time password that's valid for one-time use, obviously, and it's valid for a certain amount of time. And some of these apps also have a push-based system, which means that you don't even have to copy and paste that one-time password in your application. You just get a push message and you say allow or deny when you get the push message, and the same thing happens automatically. But this relies on a shared secret, so there's always going to be a shared secret between the application and the authentication service, and if this shared secret leaks, anybody can create those one-time passwords, so you're still relying on a vulnerable password secret kind of thing. Then there's social. Well, I have so many examples. Who uses social once in a while? Social login. I use it as much as I can because I think it's very convenient. And the reason is I have one less password to remember, even though I use a password manager. I usually log in with, let's say, Google. And if I know that there's an option to log in with Google, I know that I will probably have used this one. And I only need to remember my password to Google, even though I don't because it's in my password manager. It's one less password to remember anytime you use social login. And it also means that you give your passwords to a server you trust. Usually you have a list of social providers, and you often choose the same one because you trust that service maybe a little bit more than others. Even though any service can get breached, you usually choose the one that you like best. But it also means that you rely on other servers for your authentication, which means that if Google goes down or Google authentication goes down, people can be locked out of your services. You will not be able to log into services that you've used login with Google with, so that's a big downside. And one-time passwords are often used as a second factor. I've touched on this a few times with the examples before. Often you log in with a username and password, and then as a second factor, you have one of those one-time passwords. But it doesn't have to be. The Slack magic link example and email, for example, can be a first factor where you just click on that link, and without entering any password or username, you will be logged in. So it can also be as a first factor. Cool. Let's get to the part that really gets me excited, and that's actually the main point of this whole presentation. The rest was just something you can forget, except don't store your passwords non-hashed or as a plain text. But the Web Authentication API is an API implemented by browsers, and is often abbreviated as WebAuthn. Who's ever heard of WebAuthn before? Cool. I think I can teach something to most of you. That's exciting. So the Web Authentication API is a key-based authentication API built inside of browsers, which basically means that it uses a private and public key pair to authenticate instead of a password. And you might think, private and public key pair, that sounds way too complex for me. It's not, hopefully. Let's see. It also uses a hardware authenticator, which means that it relies on a piece of hardware to create those public and private key pairs, to store them secure, and to use a private key to sign challenges to authenticate. And they often look like this. Who is one of these? A few people. There's so many types of them. I don't think I could take a picture with all of the existing ones out there. These are the ones that I have, and they go from YubiKeys to Titan keys to Bluetooth thingies to something fancy with a screen that I once got from somebody. But they all do the same thing, or can do the same thing. They can create a public and private key pair, keep that secure, and use that private key to authenticate you into your services. And you can attach them to any device with a bunch of different mechanisms, USB, USB-C, USB-A, depending on which authenticated device you have, and depending on which device you want to plug it into. Lightning if you have an iPhone, Bluetooth Low Energy if you have an Android phone, or NFC if you have an Android phone or an NFC-capable device. You can connect them to almost any device in any way you can imagine. Already asked this, who has one? So if we use the same example as before we had a username and password, and I wasn't really great at typing, and luckily I don't have to type my password anymore. So if now we only ask the user for who are you? Do you want to log in? That's cool, but I have to know who you are before I can log in. So I type my username, and I click on login. My browser is going to ask me, can you please touch your YubiKey, which I have in my laptop. I am on localhost, so it asks me to confirm that again. If you do this on an HTTPS, because you always have to use this API with HTTPS websites, it's going to ask you once, and then after that, it's not going to ask you again. But on localhost, it will ask you anytime you try to authenticate. But once you do so, I touch my YubiKey, I get back a bunch of data, including the ID of the private key that we just generated. And the cool thing is that most modern devices have a built-in authenticator device. And I just asked all of you who has one of those devices, and I saw 5 to 10 hands go up. Now if I ask all of you who has a device that's younger than 15 years, 10 years, I think all of us can raise our hands because we either have a phone or a desktop or laptop or any device that's quite recent. And they all have one, or at least one certain chip in their chipset that does exactly the same thing. It knows how to create public and private key pairs, and it knows how to keep those secure, and it knows how to use a private key to sign challenges. So anybody with a modern device can do the same thing without actually attaching one of those YubiKeys to their device. So same example as before, but instead of using the ones I have attached to my computer, I'm going to use the one that's built into my MacBook. Now, my MacBook has Touch ID, which means that I can use Touch ID to unlock the chip in the MacBook, and then use the private key that's on there to authenticate. So my browser is now asking me, can you please touch Touch ID? I do so, and once I do so, I unlock that chip. I create a new private and public key pair, and I use a private key to do what I need to do to authenticate. And in the end, I get the ID of the private key back. So the same thing as before, I just use my laptop instead of an external YubiKey attached to my device. Pretty cool, right? Right? Just making sure you're not sleeping. Sorry. So how does this work? The first thing we need to do is create new credentials. Just like when you register a user with a username and password, you need to let them actually register. So what you're going to do is create new credentials. New credentials are a public and private key pair. And they're always generated in pairs. They're always mathematically linked. And you always use them in pairs. So the user is going to say, hey, this is my username. Can I please register a new set of credentials? The browser is then going to do a request to your backend, and it's going to send a challenge. Now, a challenge is an array buffer with random data. The reason why we do this on the backend and not on the front end is because we want to have a cryptographic, secure, random array buffer, which can be done in the browser, but not always. So we usually do this on the backend, but it's basically an array with random data that we get back from our backend, relay to the front end, and our browser is going to send this to authenticate a device. It's then going to ask for user interaction. You might have noticed that I had to touch my Touch ID. I had to touch my YubiKey in the first example. There's always going to be some sort of user interaction in order for me not to just leave my key attached to my computer, somebody running a script and trying to log in or create credentials in my name without me knowing this. So there's always going to be some form of user interaction. User interaction does not mean user verification. Me touching my YubiKey does not verify it's me, but it verifies that somebody at least touched it. Me touching Touch ID does verify it's me based on my fingerprint. But you do some user interaction, and after you've done all of that, you basically create a public key pair and send back the signed challenge, which you signed with the private key together with the public key and the private key ID, so you can identify the private key in the future. And you can store all of that in your database. And once registered, you can authenticate. Again, the user says, it's me, it's Sam, I want to log in. You're going to check into your database. Do I have a private key ID for this? Does this user already has registered credentials? If so, we send back the private key ID so we can reuse the same private keys we registered the first time to sign a new challenge, relay this to our authenticator device, user interaction, and send the signed challenge back together with maybe the public key again, so you can use that public key to validate that the same private key has signed that challenge. And you basically authenticate with a private key instead of a password. So, how does this work? This is a JavaScript conference. I have to show some JavaScript. And the cool thing is, this is a browser API, and browser APIs are all exposed as JavaScript. So we can run navigator.credentials.create, which is the method you can use to create a new set of credentials, to create a new set of public and private key pairs. And it accepts a bunch of configuration. Firstly, the challenge, the random array buffer. Next up, some information about the service you're trying to log into, your relaying party. Some information about the user, name, display name. You might add an ID as long as the ID is not personally identifiable by other parties, only by yourself. Some information about all of the credentials, all of the algorithms you know how to use. So you can set an array of arrays you know how to use on your backend to the authenticator device, and it will then choose the first one in that list that it also knows. So you both know the same algorithms and use the same algorithms to sign the challenge. A timeout, how much time the user has to complete the touching of the Touch ID, the whole action, the whole authentication action in milliseconds. And you can exclude certain credentials if you want to. Lastly, you can also choose and specify a few authenticator parameters. First off, platform or cross-platform, if you want to only allow the built-in ones, if you only want to allow the external ones like YubiKeys, and if you leave this blank, the browser will ask the user, do you want to use either of these? Same thing if you want to have only allow authenticated devices that you do user verification. Like I said before, my YubiKey didn't verify it was me, it just verified there was somebody touching it. My Touch ID did verify it was me, so that does user verification on top of the user actually just verifying that there's somebody there. And lastly, require resident key, we'll see in a second. Cool. So once you've created those credentials, you can use them, and instead of using navigator.credentials.get, you use navigator.credentials.get. Same thing again, you can pass along a challenge, an array buffer, and then you can pass along a list of credentials that you would allow the authenticated devices to be used. These are going to be the IDs of the private keys that you've stored in your database linked to your users. And lastly, you can again say user verification preferred, yes or no. So what do you do on the back end? Creating a new credential, you get back something that looks like this. A JSON response comes back from the navigator.credentials.create method. It contains things like the raw ID and ID of the private key, the type of response, which contains client data JSON and an attestation object. I'm going to go through this quite fast because it's quite complex to validate all of it, but we're going to see a few steps how you can validate these kind of objects when you get them back. The client data JSON basically tells you a bit more about what happened. It was at webauthn.create. The original challenge that we sent was this one, and the origin is the website that you're trying to authenticate with. And the attestation object, is going to contain some more useful information, like the public key that is linked to the private key, which you can store in your database to validate future challenges and so forth. So what you need to do in the backend is validate the returned authenticator data. Is there an ID? If there's no ID, no private key has been created, at least that you know of, so you can't use this object at all. Next up, validate that the challenge is the one that you actually sent to the authenticated device. If it's a different challenge, something went wrong, somebody tried to do something malicious, that's not okay. And if the origin isn't the one that you're trying to log in with, well, that's also not okay. Then you validate the attestation data. Is the user verified? If you want this, yes or no. And lastly, you can then just save the credential ID, the ID of the private key together with the public key data in your database. And when you want to verify, which means when you want to authenticate a user, you get back something like this. It looks the same, it also has client data JSON, and it basically, what you need to do is validate the user, the challenge, and the origin again, is this a challenge you sent, is this the origin you sent, is this a user you try to authenticate, and lastly, validate that signature based on the public key you have stored in your database. Do I still have time? I think so. I don't know. Yes, cool. The one cool thing is resident credentials. So wouldn't it be cool that instead of me having to type in my username all the time, I could also get rid of usernames? So not only passwords, but also usernames. I'm very lazy, I already told you this, so this seems like a cool idea to me. And you can actually store user credentials on your authenticated devices. There's a limit most of these devices have. I think my YubiKey, no, I'm afraid to say a number, but it's quite limited. So you should only do this for the services you use the most. But there is the option, at least in Chromium browsers for now, to save user information together with the private key and public key on these authenticated devices. And you can do this by setting require resident key to true. Now, if I go to webauthn.me, I'll share the link as well later, we have a debugger on our website, and it basically lets you run the two methods we saw earlier, navigator.credentials.create and .get, and it lets you play around with the configuration. So if I type my name as, did I do that right? Grusp, and then Italia. So basically I'm going to say, hey, it's the user with the name Grusp and display name Italia, and I'm going to enable require resident keys. So I'm going to create a set of credentials. I'm going to create a set of private and public key pairs, and I'm going to save the user information, the Grusp and Italia linked to those credentials on my authenticator device. And if I run this, my browser asks me which device you want to use. I'm going to say USB. I'm going to touch the right one. This one is pin code protected, so it's even more protected, and do it again. But in the end, I get back the same kind of objects that we saw in the previous slides. I'm not going to go through this. It just means that this was successful. Now, the next time that a user wants to log in again to your service, it's going to do the navigator.credentials.get. And instead of passing along a list of private key IDs, we're just going to say, figure it out, browser. I don't care. Just see if there's some resident credentials you can use to log in this user. And if so, do that. So if I click on this, let me set the timeout time to a bit more. But what's basically going to happen is the browser is going to ask me which device I want to use. I'm going to touch mine. It's pin code protected. Touch it again. But once I've done this, you'll see that I have a few credentials that I have ready to use for this website, including the one we just created. And if I click on this, we get some output, which means that it worked. And it's good to know that these credentials are created on an origin basis, which means that these will only be available for this website, for webauthent.me. If I run navigator.credentials.get on any other website, these credentials will not pop up. And this is the same for any credentials you create using WebAuthn. They're always linked to an origin, to a website, so they're quite phishing-proof as well. So what are the benefits of WebAuthn? They're private and public key-based, which is mostly way more secure than passwords most of the time. They're phishing resistant. Like I said, they're linked to an origin. And you only store public data in your database. You don't have to store sensitive passwords anymore. The only thing you store linked to your user is one or more sets of private key ID. The private key itself stays securely on the authenticated device, just the identifier goes into your database, and maybe also the public key so you can validate the challenges that are signed by that private key. But that's all public data. Should that be hacked, should that leak, it's always bad if something gets hacked or leaked, but it's not sensitive data, it's only public data. And you have some fine-grained control over which kind of credentials you will allow. If you would only want to allow external ones or internal ones, if you would like to prefer authenticated devices that do user verification instead of just a user presence test, you have some control over which devices you would like to use on your service. After all, they offer a better user experience because we've been used to doing Face ID and Touch ID on our phones for most apps these days. It's also nice if you can do this on the web without remembering passwords. If you can just touch it and you're logged in, it's way easier. It's a way better user experience. No more passwords. Yay. There's still some issues to be solved though, because I mentioned this is a newer API. It's not that new. I think it was finalized in October 2020. So that's more than 2 years, or maybe 2.5 years, maybe October 2019, I'm not sure, but quite some time ago. And implementation in most browsers is quite good, but there's still some issues to be solved. The first one is user credential management. Once you create credentials for a user, you cannot really delete certain credentials from your authenticated devices. You cannot say, I want to delete the credentials for this website, and that website, or this user resident key for that website. It's usually all or nothing. If you have a YubiKey, for example, you can use the YubiKey Manager software to erase everything on your YubiKey, but you cannot choose certain credentials. So user credential management is still something that needs to be improved for this to become really, really good. And if you use a Chromium-based browser, you might have the reset your security key, but I've never been able to make that work, so maybe it's just there for show. Maybe it works with certain authenticator devices. It just never works with mine. And like I said, if you use a YubiKey, you can use their software to completely reset your YubiKeys, but you cannot specify certain credentials to be erased and others to be kept. It's an all or nothing scenario. Also, cross-device credentials. This is intentionally made like this in WebAuthn. Because the credentials are stored on that chip, on that device, they cannot be removed and transferred to another device, which means that if I register a set of credentials on my laptop, I will not be able to use those credentials on my phone. I will have to create a separate set of credentials on my phone to be able to also log in from my phone or my next laptop or my tablet or any other device. So if you want to have one set of cross-device credentials, you'll need an external roaming platform, roaming authenticator that can connect to all of your devices. For example, I have one that has USB-C and Lightning, which means that it works on both my iPhone and my computer. And I can use that one for both of them, but if I decide to use a platform, the built-in authenticated devices inside my laptop and phone, they will only work with that device because of the safety involved in the way WebAuthn is created. But it also means that if you lose or your authenticator device gets stolen, you might need a way to recover your accounts, because if you don't have access to the authenticated devices, those public and private key pairs are gone, so you will maybe need a backup way to log in. This might be a password, this might be something else, but you always need a device recovery or an account recovery mechanism in your services if you implement WebAuthn. So WebAuthn might replace passwords. It does not replace token-based authentication, authorization, anything like OpenID Connect or OAuth. That's all something that happens way after you've used WebAuthn. The same thing for identity providers like Auth0. We have an WebAuthn implementation, but WebAuthn in itself does not replace us. It's just a replacement of a password. The only thing it replaces is that username and password field on your websites. It's a W3C recommendation, which means that the spec is finalized. I already mentioned this. It's quite finalized for quite some time. It works in all major browsers. So we can use it already. Any website that uses Auth0 and has this enabled should be able to allow you to use this either as a first factor or a second factor. But Google, GitHub, somebody told me earlier that NPM recently also added support for this. Most major websites have support for WebAuthn either as a second factor and sometimes also as a first factor, which means passwordless with only WebAuthn. If you use Auth0, I already mentioned this, we have multi-factor authentication with WebAuthn. You can either choose to have the platform or the roaming ones, or both if you want to, but also as a first factor, which means that we ask you for your identifier, your username or email, and if we see that you have a device that's capable of WebAuthn or an YubiKey or something attached to your device, then we will ask you if you want to use this. If you don't want to use this, you can still use a password, but if you prefer to use WebAuthn, you can do so instead. I think I'm done. This is WebAuthn.me, but because we're in Europe, we have to show these nice cookie consents. Thank you, Europe. But basically, this is a website that I showed earlier. It has the debugger where you can play around with all of the configuration parameters of the WebAuthn create and get methods. It also shows you a bit more information, and it shows you an interactive tutorial that shows you the back and forth between the browser authenticated device and your backend. It's fake. It's just a visual way to represent what's going on between your browser, backend, and authenticated device, both in the registering and in the authentication phase. So let's summarize. Boo passwords. That's my only summary. If you want to know more, WebAuthn.me is a website that I used, again with the debugger, but it also contains a bit more information and schematics and the nice interactive tutorial. And the specification can be found on the W3C website, and it's quite readable for a W3C or any technical specification. So if you don't know how to get to sleep tonight, open that, read a few paragraphs, and you'll be able to go. Our blog is full with content around WebAuthn and other topics, so if you are interested in that, you can always go to our blog as well. These slides will always be available at 1990.somebigger.tech. They might evolve, they might change a bit, but the essence will always be the same thing that I just talked about today. That being said, grazie, thank you very much.
Thank you, Sam. Any question in the room? We have just a minute before the next speaker. If you want to ask anything, this is the time.
One question over there.
If you use the authentication API on different devices, is it possible to track all these different keys to the same user? I mean, can we understand
Yes.
keys to the same user?
So the question is if you create multiple credentials on multiple devices,
Yeah.
if you can all attach them to one user,
Yeah.
so you don't have to create a new user for each of the devices
Yeah.
you're in. Yes. So what you're going to do is save multiple private key IDs and public keys for your same user. So that could be an array in your database, or this could be multiple fields linked to the same user. So yes, you should be able to save as many credentials as you want linked to one user.
Okay, thank you.
Okay, that's it. Thank you, Sam.
Thank you.